Awesome. Looks like we are at 2 minutes. Again, thank you all so much for joining us for the NASA SBIR Ignite Ask Me Anything session. We have Doug Goodman with us today from JSC to talk about the program and give you an overview. So let me hand it off to him. Thanks, Doug.
Donna, thank you. I've not seen the slide yet, but I'll say my name is Doug Goodman. I'm with the Johnson Space Center SBIR program, and I'm happy to be here. I'm actually replacing Haley Dowd, wonderful Haley Dowd, who was here who normally gives these. And we'll go ahead and start the presentation here in a second. And Donna, I'm not seeing the presentation. Should I be?
You should be. So I'm seeing it on my end.
So since I was having some technical difficulty, why don't we'll do a quick workaround where I'll just, like I said, I've got charts in front of me, and I'll let you know when I'm ready to go to the next one.
Sounds good.
And we'll wing it. That's what, SBIR, there's a lot of, we're trying new things all the time. And right now we're going to try something very different. So the title slide, I usually, I've introduced myself, and let's go to the second slide. On the second slide, we should be seeing a lot of different, you should be seeing a lot of different icons in there talking about what do we provide. And it's really interesting. So I always like things like it's early stage funding. This is seed funding that we're talking about here. So it's a wonderful thing where it's really centering on those small businesses to provide them what they're after. Now, the SBIR program itself has been around since the 80s. We are one of, I believe, 11 different programs that are involved in it. And specifically at NASA, or one of 11 agencies, I'll say specifically at NASA, we have a lot of stuff where when you're doing it, we've got marketplace that we're going for. We're going for the moon. We're going for the Mars. We've got the ISS up there. So there are a lot of different ranges, a lot of different destinations here. But also I want to emphasize we have 5 different mission directorates. All of them are within our program, and 10 different centers. A lot of people don't realize there's 10 different centers in the NASA agency. So on the next slide. And I'm hoping we're seeing the Perseverance rover. And I always like this one because a lot of people, the question is always, where could my technology end up? Where could it go? And this is a perfect example where you've got the rover. That's what you're seeing there is, I believe it's 7 different companies and 8 different technologies. This is all SBIR that is up there on Mars, or on Mars right now doing its work. But I also want to emphasize, I always like to say, SBIR is not only about that. There are a lot of, it's not only about the robotics and the tools that are there. We're going to be talking about some different sciences and things like that they're working on. I like to say there are also very practical solutions that can come out of our program. We've had some that I've seen where it's very, things that are needed. For example, on the ISS, there was a company that built for us some syringes. We couldn't have syringes on the ISS and outer space with astronauts there. It's just not safe. So they created a 2-fault tolerant syringe that could be used up there, and it has advanced our capabilities in human research. Another one I like to emphasize, this is a fairly recent one. It was through Applied Geosolutions. It was rice mapping and production forecasting. And that is something that came out of our SBIR program. It's great success. I believe they got like $2.5 million in post-phase $2 to develop that technology. Go to the next slide. Next slide, we should be looking at strategic goals. There are 4 strategic goals here, but I like to emphasize that third one because, so yes, while we do want to expand human knowledge and our presence, that those are driving forces for us, and enhancing our capabilities is a need. But what we're here for is about that catalyzing that economic growth, getting that drive, funding those innovations. And so we're there for 4 strategic goals, but today specifically, it's goal number 3. All right. So next slide. I just want to say that those goals are reflected in our mission and the vision of the SBIR STTR program, as our commitment to increasing equitable access to NASA research funding. And we'll talk some more about that later. If you could, next slide. So this one's pretty neat when we're talking the evolution of the space economy. Yeah, there's an idea in a special mentality, for an older mentality, that it is a very simple thing. It is very complex. It is very big. Space economy is marked by growth and opportunity, as the government-directed space activity dominated by a privileged few is replaced by a more inclusive model, which public initiatives coexist and work in partnership with private aims. And although private investment in space has increased, the lack of funding in areas like hardware and deep tech signals a continued important role for government investments, indicating this ecosystem that you're seeing here is truly one that benefits from both public and private investment, right? And that's it's a mutually beneficial relationship. So for the next slide, we should be seeing the Ignite pilot initiative there. On this one, I'm going to talk about some of this, that in addition to SBIR and STTR, we have that out there. That's our main line. That's what we're usually doing. The solicitation came out in January. Proposals have been accepted, and we are now in the process of reviewing those proposals. But this is a new opportunity. This is a new solicitation that we've been trying out. It's a pilot program. It's in its third year now. And as far as it's going, it is absolutely focused on the commercialization side. We're talking high growth, product oriented entrepreneurs, startups, small businesses, all working, and I do think it's all working in NASA relevant fields. All right. So on the next slide, we should be looking at something that looks like the general phases. You're going to see phase 1, 150, phase 2, 850, and you're also going to see some post phase 2 opportunities in there. But Ignite, it's different. That's very similar. Ignite is going to be different from what you're seeing in the others. It's a shorter proposal time. It's an accelerated schedule. We're wanting to commercialize so much that there's going to be an emphasis on it. So when we're looking at it, 30% of the evaluation is based on the technology's commercial potential. Initial reviews will be conducted by a third-party reviewers who have expertise in assessing that commercialization. So you can see there's a commercial fit here that we're really going for. Another thing is that we're going to limit the solicitation to a select few topics. In the SBIR proposal, if any of y'all have looked at our solicitation, there are a lot of topics there. When it comes to this program, Ignite, we're reducing that. We're going to make it a much smaller amount of topics, and they're going to be selected based on, is this something that has commercial viability? All right, is this something that can be commercialized in aerospace? All right, so the next slide. We'll see some topics here. And I want to highlight a couple of them. I know we're going to be talking about a lot of this stuff, but specifically, I want to say you should be seeing up there on the right hand side technologies, topics like technologies using NASA data to foster climate resilience. You'll see there was another one, point of use recycling for optimized space age logistics. FY23, we had one, Earth Science Decision Apps. That was dependent on climate change impacts and looking at wildfires and water management. So I say climate is not something we just started looking at this year. It is something that we have been looking at. And then on this one, the Ignite Catalyst, Donna, is that something you want to talk to, or you want me to talk to that one?
Yeah, for sure. I can start talking to this point. Thanks so much, Doug. Let me put myself on video as well. Okay, perfect. There you go. Yes, I can talk a little bit more about the NASA SBIR Ignite Catalysts. So what the SBIR Ignite Catalysts are, it's really an initiative designed for founders at any stage to learn more about SBIR Ignite and whether this might be a fit for your company, and also just for you to kind of get a glimpse into what are potential topics that NASA's interested in. Not saying that any of these topics are going to be in the final solicitation, but at least it can give you kind of an idea as to, hey, hey, these are areas of interest that we are looking at and potentially considering. And so usually for these NASA SBIR Ignite Catalyst events, it's going to be a mix of different things. It's going to be expert panels and knowledge sessions talking about kind of the general topic, talking about different knowledge tracks that might be helpful, and then also networking receptions for you to be able to connect with not only NASA SMEs, but also other folks in the ecosystem, such as other startups and investors and other ecosystem builders. And also at our hybrid events, which are in person and virtual, it'll also be an opportunity for selected companies to actually get a chance to speak one-on-one with NASA SMEs and actually other government agency SMEs as well, to really talk about their technologies and figure out if NASA SBIR Ignite is really a fit for you. And so this is a really great opportunity for you to help kind of talk about your technology, help our SMEs understand, hey, what's like in the market and what's out there, and help to refine kind of some of our thinking on the topic. And it's also a great opportunity just for the ecosystem to get together and to do some community building. So on the bottom here, we see a timeline of generally what it looks like for the hybrid events. Usually there's 15 days for the call of application to apply for the one-on-one sessions. And then we have 15 days before we make the selections and let folks know whether they're selected to join these one-on-one kind of speed dating, quote unquote, speed dating sessions with our NASA SMEs. And so even without applying to the hybrid catalyst, the knowledge sessions and the networking, that's going to be open to all, open to kind of the general public. So if one-on-one conversations isn't necessarily something that you want to do, definitely join us for those knowledge sessions and also networking sessions. And so we do have an upcoming opportunity that's coming up in May 6th. It's going to be in Chicago, but there's also going to be an option to join virtually on Zoom as well. And so the topic for the upcoming Catalyst is going to be aviation batteries. Not as relevant for the group that's here today, but if you do have any friends or know of any other companies that is working in this area and might be interested, you can feel free to point them to this bottom link that we have here at gus.com to apply for the chance to speak to some of our SMEs one-on-one. And if they have any questions, right below is that registration link for the AMA session specifically focused on aviation batteries. And here we have kind of generally kind of the timeline for Ignite. And so in addition to catalysts, we have AMAs, which is like one of these sessions that is like this one that you all have participated or participating in right now. So thank you so much for joining us. And then we'll also have kind of coaching events throughout. These are going to be webinars. So make sure you stay updated. You can always check the SBIR website on nasa.gov. That will always have the most up-to-date information and have all of the dates as to any webinars or any hybrid catalyst events or any updates on the solicitation as well. So always refer back to that site. And for the actual solicitation that's coming out for this year, 2024, that'll come out sometime this summer. And so, yeah, watch out for that and make sure to sign up for the mailing list in order to get those updates. And this is the last slide. Really, this is a way to kind of get how you can stay updated on the latest news, is really to join our community. So you have all the links on here. I'll also drop it into the chat. There's also the list of upcoming AMAs that are going to be happening throughout these next couple of weeks. And I'll also drop in the chat a Slack channel invite link. So for NASA SBIR Ignite, we've started a Slack community really for folks to continue the conversation, to ask any questions. And so please join the conversation. I'll drop that link into the chat. So if you haven't joined us on Slack already, please do today. And yeah, for any information on SBIR or STTR, I'd refer back to the website, sbir.gov.
Thank you, Donna. Yeah, so last thing I was going to say is make sure it's one point out to everyone, go back to SBIR.gov to get that there's a lot of great information about the SBIR program, not just for NASA, but through all agencies. Thank you.
Awesome. Thank you. So this is the end of the overview of the program. Let me stop sharing. And then kind of for the second part of the AMA, we're going to shift gears a little bit. We're going to shift our focus to Michael Seablum and Ken Jux, who are with us today. I'll hand it first over to Michael Seablum to talk more about his interest in climate informatics, and we'll be talking more about their interests there. So Michael, over to you.
Hi, I'm Mike Seablum. I'm the head of the Earth Science Technology Office here at NASA headquarters. And we are really excited about this program. We started a Entrepreneurs Challenge back in 2020, and it's now grown and transitioned into Ignite. And it's really focused on early stage entrepreneurs. And we believe in Earth Science, a lot of opportunities based on our Earth Science data stores, large withholdings of Earth Science information, petabytes of information that's out there, a lot of information that can be mined, and a lot of what we believe are business opportunities that can solve immediate challenges. For example, in the wildfire arena, we're looking for new methods to examine fuel loads for the pre-fire environment. We're looking for data that might augment existing products that operational agencies like the Forestry Service or NIFC or CAL FIRE are using. So augmenting some of the operational data with NASA Earth Science, Earth observation, we think that there are opportunities there. In a number of other areas where we're looking at land use, land change, disasters, to build tools for first responders and for policymakers. We're also investing in digital twins, which combine models of the atmosphere, the ocean, and the land surface with models of infrastructure and things like power grids or road systems. So there's a wealth of opportunity, we believe, to build ideas that could result in products that could be commercialized and used. We're particularly interested in helping startups to form businesses around these ideas. Traditionally, in the technology programs, we've given out grants to our field centers and to academia and to industry as well. But we find the best ideas are really when there's a company out there developing a product that's for profit, and it really does make a difference in terms of the ability of the tool to be effective. And the entrepreneurs tend to swing for the fences. And so we hope that this is an opportunity. This program and others are opportunities where you can have a sandbox to help build these ideas. And unlike ordinary venture capitalists, we're not going to ask for a piece of the company. We're going to give you funding that will let you develop some prototypes and build concepts. So would be happy to take any questions at the right time and discuss further. Thank you.
Awesome. Thanks, Mike. Really helpful to kind of get that general overview. And next, we're going to hand it off to Ken. Over to you, Ken.
Thank you. So everyone will have to excuse me. I happen to be on travel right now in England, and I'm doing this from a pub. So here's to you all. So greenhouse gases is a topic that's getting a lot of attention these days on many levels. And there are many agencies who have a lot of interest in this and interested in expanding the capabilities that exist to help get information on what's going on with greenhouse gas emissions. From the NASA perspective, our main job is to do it from satellites because we're NASA. We launch rockets, we put satellites up, and we try to do these measurements from space. But doing greenhouse gas measurements from space is really, really hard. And the main reason why it's hard is because you need to measure at a level of about a part in 1,000. That's a serious challenge. There are types of questions that one can answer where you don't need to go to that type of precision, but then space is not necessarily the right way to do it then either. So let me get back in. So on the in situ types of measurements for greenhouse gases, there have actually been a lot of small business expenditures into this area where people have actually made a lot of inroads. In particular, the Picaro instruments out there right now are kind of the go-to instrument right now for doing in situ measurements of methane, of CO2. There's some measurements of N2O. All of these are being done. So Picaro is kind of one of the leaders, but there are a lot of other players out there as well that are making quality measurements, building instruments that can make quality measurements that people are using right now. And I would say that there's room for growth there. So one of the other areas that people are really interested right now is in one particular sector of greenhouse gas emissions, and that's the oil and gas production and the leaks that associated with it. That's an area that it's getting attention on the U.S. government side and the European side, everywhere around there. I think there's a lot of potential investments that can be made on there that are potentially profitable by both small and larger type companies out there. So when you look at a particular leak source, the reason why one could possibly do that well is when you get a leak, you don't need to measure to a part in 1,000. You can measure to a part in 100 or a part in 10 even for some of these leaks. You can actually see them at those levels. Most of those measurements tend to be done with imaging spectrometers. That's an area where I think there's a lot of potential room for growth. There's a lot of potential places where people could think outside the box and how to build them much more versatile and lower cost in the long run. And I think there's a lot of interest both from NASA, from the Environmental Protection Agency, from NOAA, Department of Energy. They actually have a lot of resources right now to invest in these particular areas. The U.S. government has decided to coordinate all of the agencies doing research in this area to have us work together in ways that is actually helpful for all the agencies. So we're all talking to one another right now and trying to help one another out and figure out how to take what each one of us is doing and have it help the other agencies as we're going forward. So even though one agency may be putting investments to it, this is going to be of use for lots of other agencies where then there's potential money that's going in from these other agencies. So I could talk a lot more about it. A lot of what types of measurements one does depends on the question you ask. So depending on the types of questions you have, you would go with an in situ observation, with a low cost imaging, with a higher cost imaging. All of these things are part of the equation, and there's no one answer to do any one particular type of observation. So I can answer lots of questions as we go forward in there and give you my thoughts as to how best to attack any particular question. So I'll cut it off from here and wait for the questions. So thanks.
Awesome. Thanks so much, Ken. And we're going to start off the question and answers. And let's have Roxanne kick us off with the first question, and then we'll get into some in the chat.
Yeah, so thank you both so much, Mike, Ken, for laying the groundwork here. One thing I wanted to ask up front, because you've kind of, both of you mentioned the collection of data, the processing of data, the exploitation of data, the dissemination of data. And so one thing I did want to better understand from each of you is, I guess, in terms of how your workflows exist at NASA, as you look at companies to potentially collaborate with, can companies come from any part of that continuum? Do they need to be in certain areas? I know in the past we've spoken with companies who maybe could build an algorithm to do a part of this data piece, the data processing, but is that that also gets into, is that a big enough solution to actually go after a commercial market? So I guess to clarify, my question is, like, are there types of technologies that would prioritize in terms of where in that spectrum of using this data that's out there and making meaning of it? And so, Mike, I'll start with you, if that's okay.
Sure. I mean, there's a lot of issues just with the curation and the distribution of our data. I mean, it's a very, very difficult problem just to manage. The metadata models have been evolved over a very long period of time. So it's not always, and we've invested a lot of resources into this over the years. It's difficult still to manipulate the data, not just because of the volume, but because of the complexity of what's being measured, and trying to combine the different types of data requires a lot of knowledge about what went into the generation of the data products. So there's a lot of information that has to be made available for people to get the most use of the data. Simplifying that process, if there are any ideas out there to help us in that regard, I think that there could be all kinds of opportunities, not just for NASA, but those techniques could be extrapolated to other areas of where companies are amassing a large amount of data to understand the behavior of systems. Automobile companies, for example, they're collecting all kinds of information about performance of vehicles in real time. And it's difficult to manage that data. So I've been reading some articles on that. But taking some of those ideas from outside the agency and bringing them inside would be very helpful. So I think just the management of the information, there could be a lot of business opportunities in that area alone.
And I think I'll follow up with you really quickly, because it sounds like there are a few opportunities here, because we're talking about this problem. We also, mentioned before the problem that's more kind of about the monitoring fuel, I think, that could lead to a wildfire. Do you have other kind of real world problems like that you're prioritizing right now?
Well, going back to the wildfire problem, for example, if the whole area, investment in artificial intelligence enabled through the use of nonlinear regression neural nets. New types of neural nets are being developed all the time, and some can help reveal relationships that were not previously understood. So yes, so a better understanding of signals that would benefit, like for the wildfire community, identifying early or ignition of wildfires. We can do that today with our satellites, but the problem, there are a lot of false positives. Bring in other types of information to complement the measurement. Bring in types of machine learning could give us a better depiction of the event. Algal blooms, that would be another area where we're trying to monitor early onset of harmful algal blooms, things like that. So all types of land use, land change problems. Even in the atmosphere, trying to understand signatures that might help us with the quality control in our atmospheric models. That was a problem that we've dealt with for a long time. So yeah, there's all kinds of, I think, with the techniques for machine learning and artificial intelligence today, there's all kinds of opportunity.
Thank you. I'll cede the floor back to you, Donna. I see lots of questions coming in.
Sounds good. Thank you. So let's start with some questions that we have from the Q&A. So this is a question from Cindy Chin. She asks, for Mike Sablim, who is the best person at NASA to approach for catalog and access to all the data sources you mentioned?
You'd want to go to our Earth Data website. I'm going to try to pull it up right now to get the right website, earthdata.nasa.gov, and that should provide you with a starting point for how to access our large data stores. And then we have our distributed active archive centers, which house and curate and also generate scientific data products. So depending on the particular science field, the particular DAC, it would be there to assist you.
Perfect. Thanks, Mike. Okay, next question. This is from Solomon. Solomon asks, Ken, are sensor platforms optical and electrochemical for measuring CH4, N2O, and NOx that measure in the ppb-ppm range and can be mounted on flying tech? Fair for this opportunity?
So most of the sensors for measuring CO2, methane, etc., are optical based. And the main reason behind that is it's much easier to understand what you're measuring. Doing them kind of in an electrical chemical sense would be a big challenge for something like that. I think every technique that's going on right now has been optical, with the exception of one particular type of greenhouse gas, and that would be things that contain halogens. So things contain chlorine and fluorine. Most of these are molecules that there's a lot of concern about them. They're all ozone depleting substances. They're also big greenhouse gases. Those are all tend to be measured by mass spectrometry techniques. And the main reason why they do it is you can measure many things at once, and you can have calibration gases to then use it as a comparison, so you have a scale for everything you measure. That's why those are measured that way, as opposed to the optical methods for CO2, methane, N2O, things like that.
Awesome. Thanks, Ken. And there is someone who is asking, sorry if I butcher your name, Kyrol, is there availability of open source data regarding GHG, CO2 emissions, etc.? So Mike had mentioned a couple of different sources. Did you want to add anything to that, Ken?
Yeah. So actually, there is a new website that's being set up at the U.S. government level. It's kicked off right now. NASA's in charge of it, but it's multi-agencies across many agencies. It's called the Greenhouse Gas Information Center. You can go there for a lot of information related to well-vetted data sets related to greenhouse gas emissions. There aren't that many use cases up there yet, but that will expand over time. So I would keep an eye out on that website, watch it. It will grow over time. You will learn more as we go forward.
Thanks, Ken. And this is a question for both Ken and Mike. Manfredo asks, in the weather data informatics NASA is interested in, are you interested in technology applied to support risk management and agriculture? I think that's a question for either Ken or Mike or both.
Well, I'll
risk.
start. Yeah. So agriculture is actually a area that's very much of interest on many levels, both within the U.S. government and outside right now, because the agriculture community is really interested in to what their environmental impacts are right now. They're really interested in being good citizens of the world, so they want to know what their impacts are and how they can improve their processes going forward. So, in particular, just from the greenhouse gases, that's what I'm here for. Agriculture is a big source of greenhouse gases, in particular methane. Wetlands for like doing rice cultivation, cattle raising, all of those are big sources of methane right now. They're probably a bigger source international, it's even bigger. So that's a huge problem right now that people are very concerned about.
Thanks, Ken. Anything to add to that, Mike?
No, I don't think so.
Okay, awesome. Thank you. And just looking over to the chat here, we also have a question from Olivia. Olivia asks, what are the current AI ML techniques you're already using related to wildfires or other issues mentioned? And what are the biggest limitations of current AI ML techniques already in use? So maybe I'll shoot that over to Mike first.
So, I mean, we're using various forms of advanced neural nets. I couldn't really begin to name them all, but the PIs that are out there, they've come up with specific ones focused on specific problems. We're trying to, I guess, one of the biggest challenges, which was one of the questions, one of the biggest challenges is at the scales where we're trying to replace parameterizations. Okay, so trying to understand the very small scales that occur between the grid points of these large models. And these could be mesoscale models where we have a fire model built in, the fire model specifically to address the fire spread potential. We, in the past, have parameterized those, approximated the behavior. With machine learning, we have the ability to take observations and more accurately and from a better performance of computational performance, we can come up with better solutions. So one of the things in the wildfire arena is we're trying to replace the parameterizations with machine learning. The challenge is coming up with the data sets that are relevant. So we're trying to do more field campaigns and collect more observations. And again, a lot of the information that we've already collected could be used to help build some of these machine learning models. So all kinds of challenges in there.
Yeah, and I'll just add quickly, any machine learning model is only as good as the training data that goes into it. So figuring out ways to get better training data to improve the machine learning models is highly desired.
Awesome. Thank you both. Okay, next question is from an anonymous attendee. This person asks, do you prefer hardware or software solutions, or a mix of both?
I would say yes, both.
Yeah.
Both. both are going to be needed, no doubt.
Totally agree.
Okay, awesome. And then let's go into the next question from Angela. Angela asks, is the GHG funding for developing sensor technology, or could it be a novel system for collecting data on sources of interest that aren't well measured currently?
I would say it's both arenas would be good, because right now the existing technology has certain measurement thresholds that it's sensitive to. So we're only really sensitive to like larger emission sources. Things that we could use to get down to smaller emission sources or more broader scale emission sources, or to figure out how to use data that's more sensitive to broader scale emission sources, and have them actually infer those emission sources better. Those are highly desired.
Awesome. Thanks, Ken. A question from Krishna, who asks, please let me know what the NASA relevant fields are. So I think we've talked about agriculture, wildfire, anything else to add in addition to some of the different industries that we've talked through?
Well, I mean, if you're interested in where our research focus areas are, there is the decadal survey, which I mean, it's 700 pages. It's a lot of reading, but it does have traceability matrices toward the end, which really do identify where our priorities are. So it's a very exhaustive. It's a bit overwhelming, perhaps, but it's also very thorough and can be very useful.
Awesome. Thanks, Mike. Okay, and then a comment and question from Josh Fisher. Josh says, thanks Donna, Mike, Ken, Anthony, and team. My question is whether or not we, Hydrosat, will be relevant and competitive to the topics to be released. Are you looking for input into refining the topics right now, or are those finalized? And is it important to be supporting the decadal survey topics priorities or have complements to upcoming / current NASA missions? So I'll answer the first part. I think you've already answered a little bit of that second part, Mike, but we can add a little bit more there. But just to talk about the topics are not yet finalized. When they're finalized, you will see them in the solicitation. That will be when you can see which topics are going to be in this year's solicitation. And in terms of inputs for refining the topics, so your participation in events like these, the EMAs and the Catalyst, are ways that we're continually listening to the community and using that to refine our own thoughts about how we're thinking about certain topics. So certainly your participation in this is really helping us to start thinking differently about certain topics. And then over to Mike and Ken, if you want to talk a little bit more about the decadal survey topic priorities, or any complements to upcoming current NASA missions. So is that important to be supporting all of those?
So I will say that the decadal survey did what I expected it to. And it said all of the science related to Earth science that NASA does is important, and we should try to figure out ways to maximize what we do as best as we can. There's only so much that we can do from space, since the budget only allows us to do so much. So we need to augment to do some of the science that we can't always do from space in ways that are creative. And when we talk about creative, the creativity comes from more than just us. It comes from the community, including the small business community. So we rely on people like you to help us come up with good ideas.
Awesome.
Thing,
Mike, did you have anything
the
to add?
decadal. Oops. The decadal is more focused, like Ken was saying, on our science priorities. It is not a technology guide. It doesn't tell you how. It doesn't tell us specifically how to do the types of things. It might say things like likely measurement scenario or capability like that, but it it is not trying to guide the technology. We're trying to solicit those ideas, like Ken said, from small business and from academia and from industry. So the technology areas are wide open.
Awesome. Thank you both. Okay, and just a little plug, we also just pushed out the ending survey. So as we're entering kind of this last kind of around 10 minutes that we have, please make sure to fill out the ending poll before you go. But we still have lots of questions open, so we'll definitely try to push through those. Next question we have is from Nicholas. He says, we're developing a building efficiency platform, hardware/sensors plus analytics, designed specifically for retrofits in traditionally hard to instrument buildings, e.g., less than 50,000 square feet, sensitive sites, historical buildings. We help building operators improve energy efficiency and indoor air quality. Given the number of commercial buildings in this category, there is potential for significant impact on carbon emissions. Is this within the scope of what NASA cares about?
So I'll address that some. So all human activity that leads to carbon emissions we care about because they all contribute to it. Our open question is, what can we pull out of all of the data sources that we have to really quantify that? Things like building emissions, quantifying those building emissions. The agency that's in charge of figuring out how to quantify it and including it in reports is the Environmental Protection Agency. That's their job. They are required to put out an inventory across all these various sectors that contribute to greenhouse gas emissions every year. They do that, and they include buildings. They care about that. We work with them some and try to give them information that we have along that line. The open question from the NASA perspective is how much of the types of data that we get can actually contribute to that question relative to what other agencies can obtain that's relevant to any particular question that one wants to ask. So I'll leave it at, it's a very complicated question.
Awesome. Thanks, Ken. Okay, next question we have is from Paul. Would there be any interest in low swap differential absorption LiDAR technology for vertical profiling? If so, would it have to have a path to space-based systems, or would airborne systems also be of interest? Are there other LiDAR technologies of interest?
Well, I'll touch first on this and I'll let Mike go. Depends on what you want profiles for. There are things that we know that you can get profiles from LiDAR, and we've been working on that and we'll continue to work on that. In particular, things like clouds and aerosols, ozone, all of those things, they're more straightforward to get altitude profile information on. Things like greenhouse gases, unfortunately, it's much harder. And the main reason why is that all of the appropriate absorption parameters for greenhouse gases are in the near infrared. The near infrared does not backscatter by nature. Unfortunately, it does not. So it's hard to get profiles easily unless you're in a reasonably heavy aerosol environment, where then you use aerosols to leverage. So that's just the nature of the beast.
And I'll jump in too. So, yeah. So other areas, such as winds, we're looking at like boundary layer winds with LiDAR, even 3D tropospheric winds, we'd be interested. So like Ken said, we do invest heavily in LiDAR, both for airborne and for spaceborne measurements. But yeah, for some of the measurements, it's very difficult.
Got it. Thank you both. Okay, a question from Kyrol. Kyrol asks, would you be interested in software tools that could enhance your AI research on GHG, including solving inverse problems using optimization?
That's an excellent question. The big open question for taking advantage of all greenhouse gas observations, whether in situ, remote sensing, or whatever, is converting those observations into emissions. To do that requires very precise and traceable atmospheric models, in particular wind models. Right now, I would say that none of them are sufficient. That's an area that needs a lot of improvement. It needs a lot of community engagement with it to figure out how best to improve them. It's a wide open question. It's going to remain a wide open question for probably a decade for us to figure this out. So I would say that's an area for people who are interested in that area.
Awesome. Thanks, Ken. Okay, we also have a question from Anonymous. Are enabling and adjacent technologies included? So over to Mike or Ken.
I'm not sure I understand the question.
Yeah, if you could also put into the chat kind of what you might mean about enabling and adjacent technologies, and we can have Mike and Ken give you a little more insight there. Okay, let's move on to the next one. Another person asks, we are interested in addressing methane detection. There are many technologies that are already developed for methane detection and proposed to NASA for decades through SBIR programs. What are the current challenges for methane detection? Performance of the light source and detector, sensitivity of the sensor, size, weight, power, cost, or approach to data collection. So it looks like this question is specifically on that.
Yeah. So as I mentioned earlier, there's kind of two ways to really sense greenhouse gases, in particular methane. And that's either with an in situ observation or with a remote sensing observation. Any remote sensing observation, the quality of that observation depends on how good your detector is. Without a really good detector, you're not going to get the signal noise you need to really push your measurement threshold to get to lower and lower emission thresholds, which is what everybody's asking for. We want to be able to figure out how to get lower and lower emission thresholds. That what it requires is better and better detectors in the long run. So if you can think of good ways to develop better and better detectors going forward, there's a community out there willing to work with you. I can guarantee that they will work with you.
Perfect. Thanks, Ken. Okay, a question from Jonathan. Jonathan asks, while agency interests likely overlap with one another, what types of climate data are NASA concerned with as opposed to the concerns of NOAA or EPA, for example?
So NOAA is an operational agency. Their concern is well, I would say it's a slightly different from ours. We're interested in Earth system science, understanding how the pieces fit together, the cause and effect relationships. But we are also now with the new Earth Action Initiative, we're also trying to apply some of what we're doing to some of the challenges that we have today with climate change, for example. But we're not an operational agency like NOAA, where they have a responsibility for delivering products in a timely manner. So, and we don't do weather prediction. We are more involved our models are mainly used for understanding Earth system science. So there are significant differences.
But I will add, though, while there are differences, a lot of our goals remain the same in that everybody wants to improve the knowledge and have that transfer over to between the agencies such that we're all better off in the long run.
Perfect. Thank you both. And I think we only have time for one last question. Again, if we didn't get to your question during the session, we'll make sure to get them answered offline, and we'll include them when we send out the recording to everyone here. So last question, we'll go back to the question about adjacent technologies. So the new attempt at asking the question is, are you interested in enabling technology or adjacent technologies that are not specific to AI, but serves to address optimization and solving missing information points?
Yes, that, yes, if it's related to AI or transfer learning or those types of things, yes, the answer is yes.
And that kind of relates to the answer I gave earlier that your machine learning or AI is only going to be as good as your training set that goes into it. So the more we can improve the training sets that you need in order to do AI the right way, the better off we all will be.
Awesome. Sounds good. And so we have one more minute before we wrap up here. Just wanted to give maybe Mike and Ken and Doug some time to wrap up, maybe one sentence from each of you just to wrap up the session. And I think that'll be it for our time here. Maybe we can start with Ken.
Okay, so it's a pleasure talking to you all. And if you have any particular questions that you need on this side, you can look me up. I'm on the line, on the web. You'll find me. I can try to answer your specific question as best I can. And if I don't know it, I can refer you to somebody who will know it.
Perfect. Thanks, Ken. Over to you, Mike.
Likewise, I echo what Ken just said, and I also want to emphasize that we are really interested in fostering entrepreneurship, and I hope that this program will help achieve that goal.
Awesome. Thanks, Mike. Okay, and over to you, Doug, last but not least.
Thanks. Hey, I just wanted to echo everyone else say I really appreciate everyone who's participated in this event. I hope you will continue to consider SBIR. You'll consider this one, but you'll also go out to those websites like sbir.nasa.gov, learn more about the programs and the opportunities there. And again, thank you.
Awesome. And again, thank you everyone for joining us here today. We are at time. Please keep updated with us through the SBIR website and join our Slack community as well. We'll send out the link with the email and the recording. But hope you have a great rest of your day, and we'll see you at the next event. Thanks so much, folks.